Yes, sir. And then you give us one to try it as well.
Okay, all right. So now, as I had mentioned before, all right, guys, just to say good evening once again. So as I was saying from the previous class, we were looking at these and we were doing matrix multiplication. And in fact, we were doing general matrix multiplication. And so you would have learned how to multiply two matrices. And there are some conditions that you have to take into consideration before you can multiply matrices. Can anybody tell me what the condition, suppose what is the condition before you are able to multiply matrices? All right, you're cracking up, Miss Waysome. Would you like to say that again so that we can hear what you're saying? All right, Miss Waysome, I'll tell you what, we're going to wait until your reception is enough. We're going to wait until your reception is clear enough because I am really not hearing a thing, so I'm going to just ask someone else in the meantime. Miss Green, would you like to answer the question? What is the condition before you can multiply?
Yeah, find out the type of matrix it is.
In terms of how do you find out the type of matrix and when it's a type of matrix?
So like it's a 2 by 2 or like that.
All right, so that would not be a type of matrix, but that's what you really have to find out, whether it's a 2 by 2, how many rows by how many columns. Now, when we find the number of rows by the number of columns, we refer to that as the order of the matrix, all right? So in other words, we have to check to see if the order of the matrix, of the two matrix, the condition in terms of the two order would be what? Anybody? Miss Green? Are you back with us now, Miss Waysome? All right, Miss, I'm not hearing anything from Miss Waysome, so I guess she's probably not connected properly. Miss Dorothy.
Yes, sir.
So the question was, what condition you have to ensure that is satisfied before you can multiply two matrices in the general multiplication?
Sorry, you check to see if they does not equal or they're not commutative or something.
Okay, all right. You probably need to check back on that, Miss Dorothy. Miss Waysome, I was just asking the question, are you back with us?
Hearing me?
I'm hearing you, but your sound is a little slurred, and of such we don't hear clearly sometimes what they are saying. All right. So maybe I guess we are having a lot of weather down here in terms of rain. I'm not sure what is happening from your end, but maybe that could be a factor. All right, so I was asking the question, what condition must be satisfied before you can multiply two matrices together in the general multiplication method? Would you like to try and answer again, Ms. Waysome, and see what happened this time? Can you raise your hand, guys, if you are hearing me clearly? Raise your hand, let me get a feedback on what is happening. All right, Ms. Green is hearing me clearly. Ms. Doherty, Ms. Waysome? Are you hearing me clearly, Ms. Waysome? All right, so it seems like Ms. Waysome connection still in and out. So I'm not sure if Ms. Green had thought about the condition and how the condition is to be satisfied. Would you like to try and answer, Ms. Green?
Oh, sorry.
All right, so generally, if we're multiplying two matrices, now we have to check both the matrices. We have to check the order of each matrix. And there is a thing in terms of the order that we have to check. Now remember, the order is the number of rows by the number of columns. So this first matrix would have 2 rows, 2 columns. So let's say, based on that, this we know would be a 2 by 2. All right, so looking at the other matrix, we have 2 rows, 2 columns, all right? And remember that rows run across. So think of the rows as a straight line running across the numbers. And so we have 2 rows, and columns would be 2 vertical lines running down. All right, so for this one, we have 2 rows by 2 columns. Now, so I'm going to label this as R to be row, and this as C to be column. And this one would be row, and this one would be column. Now, the condition states, this is what the condition states, guys. In order to multiply 2 matrices, you have to check and ensure that the number of columns in the first matrix. So the matrix on the left would be the first matrix. So you have to check to ensure that the number of columns in the first matrix is equal to the number of rows in the second matrix. So when you look at the first matrix, how many columns the first matrix have? Anybody? How many columns the first matrix has, Ms. Doherty?
Sorry, these have 2 columns and 2 rows.
Right, but I'm just referring to the column only. How many columns?
Okay. 2 columns, sir.
Right, so we check the column first matrix. Now, for the second matrix, now we need to check how many rows. Give me a second, guys. All right, sorry about that, guys. So as I was saying, for the first matrix, you check how many columns. So we have 2 columns. The second matrix, you check how many rows. So we have 2 rows. So we say that in order for these 2 matrices to be, for you to be able to multiply them in the general sense, the number of columns in the first matrix must equal to the number of rows in the second matrix. So in other words, the column in the first must be the same as the rows, the number of rows in the second matrix. All right, so that is the condition that you have to check for. Now, suppose the number of columns in the first is not the same as the number of rows in the second. What do you think will happen? Anybody? What would happen if the number of columns in the first matrix is not the same as the number of rows in the second one? Say, for instance, the number of columns in the first matrix was, let's say that the number of columns were 3, right? Or should I say the number of columns was 3? And then now, for the rows in the second matrix, the number of rows would be the same, 2. Now, the question is, what do you think would happen in terms of multiplication? Would you be able to multiply the 2 matrices together? Guys? Anyone hearing me? Ms. Green, are you hearing me?
Yes, sir.
Would we be able to multiply the 2 matrices together?
I think so, sir.
Well, actually, you wouldn't be able to, because based on the rules of matrix multiplication, you will have a problem if you try to do that. And what you can do, you can experiment with matrices where the number of column in the first is not the same as the number of row in the second, and see what problem you would arrive at, right? But in reality, if you're to multiply 2 matrices, you have to ensure that they have the same number of columns in the first as the same number of rows in the second. So at all times, you want to check that before you even start to do any multiplication. Because the fact of the matter is, if you don't have the right amount of columns with the rows in the second matrix, so in this case, the number of columns in the first matrix is 2. So it means that the number of rows there in the second matrix is 2. That means that these 2 are equal, and so you can multiply. So column in the first, number of column in the first must be equal to number of rows in the second in order for 2 matrices to be multiplied. And that is the condition for general matrix multiplication. Is that clear to you guys? That's something that you have to ensure that you understand. Raise your hand if you are understanding what I've just said. Anybody else? I see Miss Green hand.
Sir, are you hearing me?
Who was that? Was that Miss Waysome? Yes, I'm hearing you clear now, Miss Waysome, if that was.
Yes, sir. Yes, sir. Can you just go over for me one more time, because I didn't get that one.
Okay, so before, when you were having problem with your network, I was asking the question, what is the condition that must be satisfied in order for 2 matrices to be multiplied in the general multiplication of matrices? So
we should have the same amount of row equivalent to the same amount of columns, sir.
All right, so you may want to think about that a little bit. So it is the number of columns in the first matrix must be equal to the number of rows in the second matrix. So we are not concerned about the rows in the first matrix. We are not concerned about the column in the second matrix. We are concerned about the column in the first matrix. Remember, this is the first matrix. And we are looking at what for the first matrix? We are looking at the column. Now for the second matrix, we are looking at the rows. Now, the condition is, in order for two matrices to be multiplied, the number of columns for the first matrix. So here, how many columns we have in the first matrix? We have 2. And then we say it must be equal to the number of rows in the second matrix. How many rows do we have in the second matrix? 2. So the fact that we have 2 rows in the second matrix with 2 columns in the first matrix, it means that the matrices can be multiplied with the general multiplication. Other than that, if these 2 numbers are not corresponding, you are unable to multiply correctly. All right. So I want you to bear that in mind. So before you jump to multiply any 2 matrices, you want to take into account whether the condition for matrix multiplication is satisfied by checking the number of columns in the first matrix against how many rows you have in the second matrix. Is that absolutely clear now? Can I see the hands of those who are understanding clearly what I'm saying? All right, Ms. Green again. Ms. Doherty. Ms. Cabrera, how about you?
Repeat, please.
Okay, all right. So let me use another example. Maybe it will come across easier to you this time, right? Now, so let's say we have this matrix here. So I have a 1 and a 2. And let's say I have this matrix here. And let me use this one here. So I have 3, 1, 5, and 6. Now, let me write that a little clearer. So now, Miss Cabrera, the question is, can we multiply these 2 matrices? Now, as I was saying, before you decide whether or not you can, write out the order for the matrices. What is the order for the first matrix? How many rows, how many columns?
1 row, 1 column.
Say that again, Miss Cabrera.
1 row, 1 column. No, 1 row alone. There's no column.
You sure about that? So we have 1 row with 2 columns. You see that? Ms. Cabrera?
Yes.
Right. So the moment you have rows, they are going across. So if you draw a line across, then that would be a rows. Now, columns will come down. So even if it's just a single number and it's 2 of them, it means that you have 2 columns. Is that clear? So,
Yes.
so based on that, what would be the order of this matrix? How many rows by how many columns? Ms. Cabrera, that's your question.
1 row, 1 column.
Yeah. Think about what you're saying again.
1 row,
1 row,
2 column.
2 columns. So this would be a 1 by 2 matrix. 1 row and 2 columns. Now, this second matrix here, how many rows, how many columns?
2 rows, 2 columns.
So it's a 2 by 2. All right. All right. I'm not going to say anything yet. I'm going to put one more pair of matrix to be multiplied on this. All right. So let's say we have another pair now. So let's say I have this one. And I have 1, 2, 3. And I have this one. I'm going to use this same square matrix here. All right, now the question now, Ms. Caveira. What is the order of this matrix here?
1 column.
Remember, when you're saying the order, you have to state the row first, then the column. So how many rows, how many columns?
1 row, 0 columns.
1 row?
The row is not the down part.
Remember, the row goes across. Remember, anytime we talk about row, we're going, all right, let us check the second one first. How many rows, how many columns for this one?
2 rows, 2 columns.
All right, so we have 2 rows. That means we have 2 set of numbers in row going across. We have 2 set of numbers coming down. So we have 2 rows, 2 columns. So that's a 2 by 2. All right. Now, how about the first one now? Go back to that now, Ms. Caveira, and tell me how many rows, how many columns?
1 row, 1 column.
All right. Oh, now you have how many numbers you can draw a line through going across? You can draw a line through this one going across, this one going across, this one going across. That's the number of rows. So you have 3 rows. What is confusing you because you're only seeing 1 number, but the fact that you can draw a line go across 3 numbers, that means you have 3 rows. And then now column comes down. So how many ways you can draw come down? 1. I only have 1 set of number coming down in a straight line. So in that case, you only have 1 column. So in terms of the order, you have 3 rows and 1 column. So this would be a 3 by 1. Is that clear to you now, Ms. Caveira?
Sir, you 3 rows, and then you say rows go across. Why isn't it 1 row and then 3? Never mind, we get what you're saying.
Let me show you something. Suppose it was like this. Putting back the 1, 2, 3, and I have 0, 4, 5. How many rows?
3 rows.
3 rows. Now, if I take away this number, how many rows?
1 row.
No, you're confusing your columns with your rows. Remember, all right, let me undo what I just did. How many rows?
There are 3 rows.
How many columns?
3 columns. 2 columns.
2 columns. Remember now, you draw a line come down for your columns, right? And you draw a line going across for your rows. All right. Now, suppose I take away these numbers on the right. Like so. How many columns do you have?
3.
How many columns do you have?
3.
All right. If we are to, how would you draw your line to count your columns?
You would write vertical.
You're not sure.
Yeah, you then write down to create a column.
Vertical, right. So this is one column. This is another column, right? Now, when I delete these, how many columns do you have?
1, sir.
One column. You understand what I'm saying? All right, let me do this again now. Now, how many rows do you have? Where do we draw the line?
3 rows. 3 rows.
So we draw the line, go across, right?
Yes, sir.
All right. Now, suppose I take away these numbers. All right, let me put back that line there. How many rows do you have?
3.
Right. So once you have 3 numbers going down, it means that you have 3 rows. You understand?
Yes.
So the amount of numbers that you have going down tell you the amount of rows. So you have 1, 2, 3 rows. All right, so if we go back down to what we have down here now with these 2 here, and we check the number of rows and the number of columns, what you would realize is that for this one, you go across 1, 2, 3, so it means that you have 3 rows. And when you come down vertical, you come down only in 1 line, so you have 1 column. For the second one, you can clearly see that you go across 1, 2 times, so you would have 2 rows. And you come down with 2 vertical lines, so you would have 2 columns. So is that clear now with the columns and row with you, miss?
Yes.
Right. Now the next part that we are looking at now is whether or not these 2 matrices can be multiplied. What do you think? Do you think these 2 matrices that we have over here, do you think that they are, if you would be able to multiply them together?
Yes, sir. I think so.
All right.
No, yes, I think so.
All right. So let me ask anybody else. Anybody else agree with what Ms. Cabrera is saying? Or should I say, does anyone else have a different idea? Or anybody disagree with Ms. Cabrera? And why?
Sir, what did she say?
She said that we would be able to multiply these 2 matrices based on how they are. What's your take on that? Miss Green, that's your question. What is your take?
No, sir, I don't think it is possible.
All right. Can you tell me why it's not possible, Miss Green?
Sir, I'm not sure why, but I just feel like it is not possible.
All right, Miss Wilson, can you some input?
Sir, Which I don't know. The one at the circle.
Yes, the one that I circled.
And what was Miss Kevera's response, sir?
All right, no, so I'm asking you the same question that I asked her. Do you think these two matrices can be multiplied?
If they can be multiplied?
Right.
No, sir.
All right. Why can't they be multiplied?
Because the column is not equal to the amount of rows, sir.
All right, so
The first column.
when you look at the column here, how many columns you have?
We have in which one, sir? The single one?
Yes.
That's one column.
All right, so let us circle it in the order. So we have one column. Now, in the second matrix, what are we checking the column of the first matrix against? The row or the column?
The row, sir.
Right. Now, in the second matrix, how many rows we have?
2.
2. So let us circle, because remember, in the order of matrix, the number that comes in the front tell you how many rows you have. Right? The number that comes after the multiplication sign tells you how many columns you have. So for the first matrix, you would have one column. For the second matrix, you have 2 rows. And what the condition is saying, if these two numbers, this one and this one, if these two numbers are not the same, you cannot multiply. So clearly so the question is, are these numbers the same? Would 1 be equal to 2? Is that possible?
No, sir.
No. No, because these numbers are not the same, meaning that they are not equal, these two matrices cannot be multiplied in the general sense. Now, Ms. Kevera, looking at this set of matrices that we have over here now, how many rows we have for the first and how many columns? Ms. Kevera?
So I have 1 row, 1 column.
1 row for the first one. This is 1 row. And when you come down 1, 2, we have 2 columns, right? So so the order is 1 by 2. 1 row by 2 columns. Now for the second matrix, how many rows, how many columns you have? Ms. Kevera, that's your question.
Rows and 2 columns.
Right.
You're right.
When we compare the column in the first matrix, which of these numbers represent the column in the first matrix? The one.
The second, the 2, the number 2.
All right, so I just put C over that one. So that is a column. So the column equal to what? 2.